Welcome to Module 17 of AP Environmental Science. This is a pretty uplifting one. We talk a lot about mass extinction, but we're also talking about where species can live and why they live there. So we're going to start with this little diagram here talking about the range of tolerance. So the range of tolerance is all the particular places that a species could possibly survive. So anywhere that it can survive, it's got enough food, it's got enough water, so it can exist there. It's not really doing great, but it's alive. Then if we go in a little bit, so this is particularly looking at temperature, it can survive and it can grow, it can thrive there. It's not on the brink of dying all the time. But if we get in a little bit more narrow to that perfect ideal area, that's what's called the fundamental niche. This is where an organism can not only survive and grow, but it's also healthy enough to be able to reproduce. Now, the fundamental niche is a pretty big concept that overarches this entire module. Thinking back to our specialist and generalist species. Specialist species require a very specific set of conditions in order to be able to survive. That's like our koala bear here. Now, koala bears are very particular about what they'll eat and where they'll live, so they have these specialized requirements. Whereas a kangaroo, they're generalists. They'll eat pretty much anything. They'll live in a pretty wide variety of habitats. So these specialists are actually at a much greater risk of becoming endangered or extinct when their environment and their habitat is being threatened. So that brings me to this fundamental versus realized niche. Now, the fundamental niche, this is where an organism can survive, grow, reproduce. So this is where, it's that location where it could live and it could thrive. But just because it could doesn't mean that it does. And this is where we get into what's called realized niche, because there's many competing factors. Like there might be another organism that also wants to live there. So the realized niche, where the organism actually lives, is much narrower than the fundamental niche. So when we get our little, all right. When we have our little arch here, the realized niche is actually a tiny little sliver. It's not this whole orange area. Too far. All right. Now, changes in the environment can change where that fundamental niche is located. And I like this spruce example because it's the most clear out of the three here. Spruce prefer a specific amount of temperature and moisture throughout the year in order to grow and thrive. Now, 18,000 years ago, we were in an ice age, and we had ice sheets covering most of the earth. Now, the spruce trees tended to kind of follow that retreating edge of ice. As it retreated northward, so did the spruce trees. So the darker greens means there's a greater concentration. And they continued moving northward. Now, 18,000 years ago, we had spruce trees way down here, but we don't anymore, or at least not naturally anymore. They've retreated up into the northern parts of North America, so those higher latitudes. So these changes in the environment are changing the fundamental niche of a species. And remember, the realized niche of where it actually is found is even more narrow than that. Here's another example of the Loblolly Pine. So that first one with the spruce, we were looking at what it was in the past. We're able to take that information and make predictions out into the future. So if climate change continues and the habitats change, organisms are not going to be able to survive and thrive in the places that they currently are. So with the Loblolly Pine, it's mostly found in southeastern United States. But if the planet continues to warm, it's going to become way too hot in the southeastern part of the United States for the Loblolly Pine to survive. the ideal temperature is going to slowly start creeping northward. So it's predicted that in the year 2100, the Loblolly Pine will be found in parts of the southern Michigan and in parts of Illinois and Arkansas. And it's never been there before. Or I'm sorry, Missouri, not Arkansas. But not all trees, not all species are able to move as quickly as would be needed for this to be able to happen. So we're able to look at what was around in the past, and that's our fossil record, and we're able to see how that biodiversity of the fossil record has changed over time. So we are looking at the biodiversity of 100,000 years ago, or 100 million years ago. We're able to look at the rocks and look at the fossils, and we're able to figure out what's the variety. Is there a lot of different organisms or not very many organisms? So we're using carbon dating to figure out the age of the fossil, and we're comparing the ages of all these different fossils to see what we've got at different points in time. Now there's 5 major recorded mass extinctions. The one that wiped out all of the dinosaurs is right here. It's kind of sad. Dinosaurs are cool. Sometimes I wish we had them, but not really. They're terrifying. If we lost all the dinosaurs there, we also lost a whole lot of other species as well. There was a lot of the megafauna of North America got wiped out in that same mass extinction event. The reason why we have more biodiversity today is likely because things like insects, the really tiny small ones, they're not very well preserved in fossils. So it's a lot more difficult to count the number of very small organisms in that fossil record. It's much easier to count the big ones. So I would make the argument that even though it looks like there wasn't a whole lot of biodiversity here, it was probably actually pretty close to what it was up like more recently, but these mass extinction events still happened. They still had these big losses. Currently, because humans are humans and humans are sometimes pretty terrible, we are in the midst of the 6th mass extinction. So we are currently losing, estimates range between 24 and 150 species every single day. That's a lot. If we're losing that many species every day, it will be pretty quick. I'm going to make a really tacky analogy. It will be a pretty quick amount of time before we go from having this big, beautiful buffet of a ton of different food to choose from to only being able to eat chicken nuggets because that's all that's available. There's going to be this huge reduction, and it's going to impact humans pretty significantly because I personally believe that humans are going to be one of those species that go extinct. And once humans are gone, it's going to come back up. Yay. All right, so some of the causes of the 6th mass extinction. Humans being dumb, we're destroying their habitat. So we're destroying the places, we're destroying the fundamental niche of these species. So if a pond that a salamander lives on the shores of, and it's the only place that that species of salamanders lives is in this one particular place, one particular pond, if we dig up that pond or fill it in and turn it into a parking lot for a shopping center, that habitat's been destroyed. That entire species is now gone forever. Humans are also really great at overharvesting. They're really great at adding pollution to the environment. And we're really great at adding carbon dioxide to the environment, causing climate change, and then not doing anything about it. We're also really great at transferring species from one place to another, especially generalist species who then take over. And there's a lot of new diseases that are coming about because of the changing climate that are wiping out the genetic diversity and the biodiversity of organisms. Yay! That was a lot. That was kind of depressing. However, this working towards sustainability is pretty uplifting. So it talks all about how the Nature Conservancy is working to promote and protect biodiversity. And their biggest strategy is purchasing land so it can't be developed, and then managing that land in order to promote all of the things that live there, all of the natural things that live there. So they're trying to expand that fundamental niche of an organism, so they're trying to improve the conditions so it has a greater area of land or water that support that fundamental niche, so it can compete with the other natural biotic other organisms to create its larger realized niche. When you have a larger realized niche, your species is far more likely to avoid extinction. Pretty great. So read through there. It's pretty uplifting, pretty great. I'm sorry it was kind of depressing. Take good notes, bring your questions to class. Let me know what you think.